Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T with another algebra tutorial. Today we're talking about dividing polynomials using something called synthetic division. Now, synthetic division is a special kind of division that works when we are dividing a polynomial by a linear factor. So meaning our denominator is going to be x and then plus or minus a number. If our divisor had a number in front of the x, as shown here, say 2x minus 3, this is supposed to be an exponent, so if this had a denominator that was, say, x squared minus 4, neither of those two denominators could we use synthetic division. We would have to use long division, and that's a different topic, a different tutorial. If we had divisors of x minus 3 or x plus 5, x minus 7, etc., we can use synthetic division. Now, there is no limitation on the type of polynomial in the top of the dividing, the numerator, but we do have limitations for synthetic division. So let's go through a couple of examples. Now, when we are dividing, so we have our first example here, we want to divide these two polynomials. Our first step is we need to find what I would call the zero of the denominator. What's the value of the denominator? Or what value of x makes the denominator equal to 0? So if we set the denominator equal to 0, we get x equals 3. So that's the 0 of the denominator. Now, for the numerator, our polynomial here, we have to have a complete polynomial with no missing terms. So this polynomial has an x cubed. There's no x squared, so it's missing a term. Now, we want to rewrite that polynomial adding a x squared term. So if I want to add an x squared term, I have to put a coefficient of 0 in front of it, because this polynomial is equivalent to this one, because 0 times anything is 0, so that would disappear. Now, when we set up with for synthetic division, we're going to use kind of an upside down divide symbol, and our 0 that we had here will go out to the left. And our top row, you're going to need room for 2 rows of numbers here. The top row will be the coefficients from our numerator. So the coefficients are the numbers in front of the x squared as well as this. And that would include the leading operators there. So we have 3, 0, 5, and negative 2. So this would be how we set it up. Now in this next slide, we'll go through actually doing the synthetic division. So I've got this set up again. So the process is described here. We're going to bring the first coefficient down. So we're going to bring this 3 down. And now, until we get all the way across, we're going to do 2 operations repeatedly. We're going to multiply whatever the most recent number is on the bottom times our 0 over here. And then we're going to put it over in the next column. So I'm going to take 3 times 3, which would be 9, and put that here, and then we're going to add. So 0 plus 9 is 9. Now we're just going to repeat that. So 9 times 3 is 27. Put that here, and then I add. 5 plus 27 is 32. Our last one here, 32 times 3 is 96. 96 plus negative 2 is 94. So we've completed the division. Now we need to interpret the results. When we interpret the results, we divide these numbers on the bottom row into 2 parts. The last number is our remainder. Remember when you did division of numbers in grade school, numbers don't always divide evenly, and we sometimes have something left over. We have our remainder. These numbers are the coefficient of our answers, so the coefficients of our answer. And when we divide a polynomial, So if I divide a polynomial of x cubed by a polynomial of degree 1 in x, my x's are going down by 1. So every time we do synthetic division, the coefficients of this polynomial, it's a polynomial of 1 degree less. Remember, the degree is the leading exponent. So our original problem started with a x cubed. So these coefficients are for an x squared. So if we write our answer here, we've got 3x squared. So again, this 3 coming down here. Now we have plus 9. So plus 9x, and then plus 32. And then we have to include our remainder. If you remember from doing division in grade school with just regular numbers, we take the remainder and form a fraction by putting it over what we divided by, and we divided by x minus 3. And this would be our answer. This would be the result of that division on the previous page. So let me go through two more examples just to help give you some additional ideas to look at. So again, here we are missing a x to the 4th term, so we're going to have to add an x to the 4th. And we're missing an x term, so I have to add 0x. And on the denominator, if I set that equal to 0, I'm going to get negative 2 for my 0. So we'll put the negative 2 to the left. We will make our division bracket. Across the top, we'll put our coefficients. So this coefficient's missing. It's an invisible 1. And now we have our 0. Got to put them in order by decreasing exponents. Negative 3, positive 2, 0, and negative 8. Now remember, we bring this first number down. And now we're going to multiply and add. 1 times negative 2, add. Negative 2 times negative 2 is plus 4. Add, we get plus 1. 1 times negative 2 is negative 2. We add, we get 0. 0 times negative 2 is 0. Add, we get 0. 0 times negative 2 is 0. We add, we get negative 8. So remember, this is our remainder, and these are the coefficients of our polynomial in our answer. So our final answer for this problem here would be, now remember, this was an x to 5th, so this is an x to the 4th. So it would be 1x to the 4th minus 2x cubed plus x squared. And then this would be 0x, which we won't show, plus 0. And then we have to add our remainder, plus negative 8 over x plus 2. Now we can write it this way, or you will also see it frequently written like this, where we'll bring this minus down here, and we could write it that way. So I'm happy for you to write it either way. And let's look at our last example. So here we're not missing any powers. We have an x squared, an x to the 1st, and a constant. So all we have to do is figure out our 0 on the denominator. So that's negative 5. And we have a 4, a 13, and a negative 35. So we bring the 4 down, multiply, we get negative 20. Here we get negative 7 when we add those. Negative 7 times negative 35 is positive 35, and we get 0. Now this time we got a remainder of 0. So that means this factor divides evenly into, or this denominator divides evenly into our polynomial. That means this is actually a factor of that polynomial. We'll be talking about that more in the next video. So our answer here would be 4x minus 7. And then I don't have to show the remainder here, because if I put plus 0 over x plus 5, 0 over something that's non-zero here is 0. So we wouldn't show that. So in this case, x plus 5 divided evenly into this. So this would be like if we had the number 8 and we're dividing it by 4. 4 divides evenly into 8. So there's no remainder. So again, x plus 5 divided evenly. So I hope this helps. Good luck with synthetic division.
Are you ready? Are you ready? Oh,